In this video, we're going to be looking at the mean in relation to the median. More specifically, how the data distribution can affect the mean, along with how outliers can affect the mean. Remember, data distribution is how the data is distributed, whether it's left skewed, right skewed, or symmetrical, and then outliers are numbers that are far away from the rest of the data. And how do those things affect the mean? Let's take a look. So here is a graph of hours of sleep that students got last night. If you look at this data and I asked you, hey, what's the average number of hours of sleep a student got in this class, or what's typical, what's in the middle of the data in terms of how many hours of sleep did a student get in this class, what would you say? Now, here's where we would use measures of central tendency to determine that. I can see that the mode is 8 because it's the most popular, right? So that's the mode. But let's look at our mean and our median, because those are the two we want to see. Mean here is 7.6. So if I put a little triangle on my number line, it's right around there. They're saying that's the average, where the median or the middle value is 8, which is right here. So why is the mean pulled lower than the median? Well, it's pulled lower because if you look, the data is left skewed. So because it's skewed left, it's going to drag that mean down from the median. And we also have an outlier here. We had one kid in this class get 2 hours of sleep. Now, what does this all mean? Well, the average or mean is a little misleading because it makes it look as though the typical amount of sleep that a student got was about 7.5, 7.6 hours of sleep. When in reality, most of the class got either 8 or 9. So that measure is lower than the median because of how the data is skewed and because there is a low outlier. Let's see this in some other situations. Here is a fantastic example of how many pets do you have. So a class was polled. This is how many pets students had. Now, overall, when you look at the data, you can see that this data is skewed. How is the data skewed? Hopefully, you see that the data is skewed to the right because most of the data is on the left. Most kids had between 0 and 2 pets, but there were some kids that had more than that, and there was even a couple kids that had some extremes. So we had an 11 and we had an 8. Whether those are outliers could be judged, because there are some students out here. 11 kind of is an outlier. 8, I mean, it's relatively close to these other numbers, so I don't know if I would call it an outlier, but these numbers are skewed. They're skewing the data to the right. Now, what that does is it's going to pull the mean. It's going to pull the mean to the right. You can see the median here is 1, which is a great measure of normal for this group because most kids had either 0, 1, or 2, so 1 is a good in the middle central tendency measure. It's also the mode. But mean is 2.14. That's all the way up here. Now, if you look with most of the data being down here, that is not the center of the data. That's not a good measure of central tendency to use here. And the reason is because the data is skewed to the right by all of these outside values. They're all making it seem like the average number of pets is much higher than it is. So the mean is kind of a poor choice here. It's being dragged higher because of how the data is skewed and because we have some of these values down at the extreme here that are, remember, those are called outliers. Now here's another example. This is age of 6th graders in math class. You'll notice the data is perfectly symmetrical here. And because the data is perfectly symmetrical here, what do you think that will do to the median and the mean? The mean and the median are actually identical here because it's perfectly symmetrical. when data is either perfectly symmetrical, if the data is perfectly symmetrical, the median and the mean will be exactly the same. If it's mostly symmetrical, they're going to be close. And so really either one of those measures is a fine measure of center, because they both can tell you, and actually it's the mode too, both can tell you where most of the class is 11. Again, this is age of 6th graders. So yeah, the average age of a 6th grader is 11. The median age of a 6th grader is 11. And the reason that works is because the data is perfectly symmetrical. It's not skewed one way or the other. I'll go over one more example. So in this last example, we have cups of coffee that were drank this morning, and you can see most people were either 1 or 2 in terms of how many cups of coffee they drank. But I do have a 10, so I do have this outlier out here, right? And the data is slightly skewed to the right, but really the problem is I have someone that drank 10 cups of coffee. That's a lot of coffee, when everyone else drank either 1 or 2 cups. So what do you think will happen to the mean? Will it be above or below the median? If you guessed above, you are correct. The median here is actually 1. And the reason that is 1 because we have a lot of people here, and in fact we have 10 pieces of data. So if I counted 1, 2, 3, 4, 5, there's my first half of my data. And then my second half of my data is everybody else. So the middle of the data is actually 1. But the mean, and actually let me just erase this here, the mean is 2.2. That's extremely high. In fact, that's higher than everybody other than the outlier. The average amount of coffee drank in this group of people was 2.2 cups. That's very misleading when the vast majority, in fact, everyone but one person, either drank 2 or less cups of coffee. So this is a great example of how just an outlier, just having an outlier, can skew the mean to an extreme and make it very misleading. So average or mean isn't always a great measure of central tendency when you have things that are at the extremes.